Good day, everyone. So, have you guys ever wondered what really happens when two objects collide? For example, like when two cats crash into each other, or when a ball hit the wall and bounces back.
Tennis ball, throw it against the wall. Bounce, 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 bounce.
So in physics, these situations are studied under momentum direct impact, where it involves momentum, impulse, and also collision. So in this video, me and my group mates will focus on collisions in mechanics. So there are two types of collisions, which are inelastic collisions and also elastic collisions. In inelastic collisions, objects do not bounce apart, while for the elastic collisions, the objects will rebound. So in this video, we will firstly explain about the inelastic collisions and solve a typical exam style questions, followed by explanation about the elastic collisions. So let's get into it. Let's begin with inelastic collision. This collision involves the objects do not bounce apart and the momentum is conserved but not for the kinetic energy. The objects stick together, therefore they move with common velocity after collision. Now let's do a question related with inelastic collisions. So there is a 3 kilogram cat is jumped at a speed of 20 meters per second into a 1.2 kilogram swing that hangs by a vertical string. The cat remains on the swing. So, what is the final speed of the cat and the swing? And how high will the cat swing system rise? Okay, to solve this problem, we must first list down all the informations given. So, the first one we have mass of cat. So, we write M1 equals to 3 kilogram. And then we have mass of swing. So we must ensure that all the units is the same, which is in kilogram. And then it is given that the speed of cat is 20 meter per second. So that is the initial velocity of the cat. So U1 equals to 20 meter per second. And then the swing is hanged by a vertical string. Therefore, the string is static. So the initial velocity of the swing is 0. And then we need to find the final velocity of the cat and swing. So for this questions, we must use this equation, which is M1 U1 plus M2 V2 equals to total of mass plus Vf. Because since this is the inelastic collision, the final velocity of the two objects is equal. Okay. So we just substitute all the values into the equation. So M1 is 3 kilogram, U is 20 ms plus 1.2 0 equals to 3 plus 1.2 kilogram and final velocity. So this equals to 0, and then this is 60. So 60 over 3 plus 1.2 equals to final velocity. So our final velocity equals to 14.2 at 6 meter per second. So the final velocity of the cat and the swing is 14.2 at 6 meter per second. Let's answer question B. So since this is the inelastic collision, during collision, KE was lost, but the energy is conserved. Therefore, it is actually the kinetic energy is converted into potential energy as the block moves to the high position. So, we do kinetic energy equals to potential energy, where the kinetic energy equals to half mv square, and then the potential energy equals to mgh. So m both side we can cancel out, and then we left with half v, which is the one that we got in question A, 14.2 at 6 square equals to g, 9.8 equals to h, the one that we want to find. So just move to the left hand side. Solve like usual. 10.413 meter. So this is how high will the cat swing system rise.
Now, let's move on with elastic collision. An elastic collision is a collision where the objects bounce apart after impact. In elastic collisions, both momentum and kinetic energy are conserved. That means there is no loss in kinetic energy during the collision. To add, these elastic collisions can also be described using the law of restitution. This law states that the speed of separation is equal to the speed of approach along the line of impact. For a perfect elastic collision, the coefficient of restitution is equal to 1. Next, my group members will explain about the 3 cases of elastic collisions using the exam-style questions.
Case 1. In a daily life, we often observe a moving object collide with another moving object. But now, I will focus more on the moving object that collide with the stationary object. For example, we have a moving card that collide with the stationary card situation. We also have an example when we play snooker, and also when we play traditional game which baling slipper. So now, I am going to demonstrate a collision for this case using simple objects that we can easily find at home. This video can give all of you more deeper understanding about elastic collision for case 1. In this video, I use a tape with an orange tag that represent object A, while the tape with a green tag represent object B. At the beginning, object A will be moving toward the object B, while object B stay at rest. As object A move forward, it collide with object B, and after the collision, we can observe that object A come to rest while object B start moving forward. So, this situation show a specific collision where momentum is transferred from object A to object B. Since object A stop after the collision, it indicates that its momentum has been transferred to object B. So, this type of collision can be analyzed using the principles of conservation of momentum. Let's do a question related to this case. A blue drinking water of a mass 1 kg is moving with speed 6 meters per second on a smooth horizontal table. Then, it collides with a static mountain drinking water. If blue drinking water comes to rest after the impact and given E equal to 1/2, find the speed and mass of mountain drinking water after the impact and the loss of kinetic energy. So now, I'll be showing on how to solve this question. So first, we need to lay out all of the information that we have in this question. So first, blue drinking water. It have a mass 1 kilogram and it also have initial speed which is 6 meter per second. And then we move to the next sentence. It said that it's collide with the mountain drinking water which initially at rest. What mean initially at rest? It means that the mountain drinking water also have initial speed which is 0. And then we move to the next sentence. It said that the blue drinking water come at rest after the collision. It means that the blue drinking water have a final speed which is 0. And then the question also gives us the coefficient of restitution which is E, which equal to 1/2. So before we move to the working step, we need to make our working step more easier. Then we can let the blue drinking water as A and the mountain drinking water as B. Okay, so first step, we use the law of restitution, which means that our E is equal to the velocity of suppression that happened after the collision divided by the velocity of approach that happened before the collision. So, our E is equal to the VB minus VA over the UA minus UB. That is also equal to 1/2. And then, for the VB, we can state as a VB because we don't know our VB value yet. And then for the VA is equal to 0. UA is equal to 6 and for the UB is equal to 0. After we settle the equation, we can get the value of our VB which is 3 meter per second. Now, for the second step, we use the principles of conservation of linear momentum where the total initial momentums are equal to the total final momentum. So, from this, we can get an equation which is MAUA plus MVUB equal to MAVA plus MVVB. So, we can fill all the value inside this equation and when we settle both sides, we can get 6 equal to 3 MB and bring 3 to the other side, we can get MB equal to 2 kg. So, the mass of mountain drinking water is 2 kg. Then, we can proceed to another question which is the loss of kinetic energy. As we know, the formula for kinetic energy is 1/2 times m times v square. So, in order to find the loss of kinetic energy, we need to find kinetic energy of initial and kinetic energy of final. So, for kinetic energy initial, we can get from 1/2 ma times ua square, which is 1/2 times 1 times 6 square. That we got 18 joules. And for the kinetic energy of the final, we can get from 1/2 mb times vb square, which is 1/2 times 2 times 3 square, that we will get 9 joule. So, when we get both the kinetic energy initial and kinetic energy for the final, we can find the loss of kinetic energy. The loss of kinetic energy can be found by kinetic energy initial minus the kinetic energy for the final, which means 18 joule minus 9 joule, where we can get 9 joule. So, in conclusion, the loss of kinetic energy is 9 joule. So now we can conclude all the final answer. So first, the speed of mountain drinking water, which is 3 meter per second. And next, we have the mass of mountain drinking water, which is 2 kg. And last but not least, we have the loss of kinetic energy, which is 9 joules. In conclusion, by applying the principles of conservation of linear momentum and also the given coefficient of restitution, we can find the speed and also the mass of the mountain drinking water. And for the lost kinetic energy, we can find from analyze the change of kinetic energy during the collision.
Now, let's learn the next case of elastic collision.
Now I'm going to explain the second case of elastic collision. Before the collision, two objects with mass m1 and m2 move toward each other with speed u1 and u2. They collide head-on. After the collision, both objects bounce off and move in opposite direction with speed v1 and v2. Now let's look at one example of a question that involving the elastic collision of case. So the question is, Toyka P and Toyka Q are moving along at a smooth horizontal route in opposite direction. Toyka P has a mass of a kg and is moving to the right with a speed of 4u ms negative 1. And the Toyka Q has a mass of 3a kg, is moving to the left with a speed of ku ms negative 1, where k is a constant. The Toyka is collide directly. After the collision, the direction of motion of each car is reversed and the speed of each car is reduced to the half of its speed before the collision. So for the first question is find the value of K, and the second is find in terms of M and U the magnitude of impulse that acted on P by Q. So before we answering to the question, let's understand the motion of the car first. So let's answer to the first question first, which is to find the value of K. So what we need is we need to list down all the information given in the question so that it can be easier for us to answer. So what we get from the question is MP is equal to A, MQ is equal to 3A. The speed before the collision we use U, so UP equal to 4U ms negative 1, UQ is equal to negative KU ms negative 1 because of the Q is moving to the left. And for the speed after the collision we use V, so VP is equal to negative 2U ms negative 1 because of the question just tell us that the speed of after the collision is half of the speed before the collision. So the VQ is KU over 2. So let's use the formula MPUP plus MQUQ equal to MPVP plus MQVQ. So let's just put all the information that we have and then answer to the and answer like before, and the last answer we get the key, which is K is equal to 4 over 3. So let's move on to the second question, which is to find the impulse exerted on P by Q. So what we need to know is we need to know the formula of impulse. So impulse is equal to delta P equal to mv minus mu. So we use this formula to solve this question. So delta P equal to mpvp minus mpup. So just use the information that we get from the question and then solve like before, and we get negative 6 mu. So the answer is we just write the answer in the positive. So the answer is impulse exerted on P by Q is equal to 6 mu.
Case 3. What happens if the faster pole hit the slower one from the behind? Do they stop, bounce back, or move together? Two balls A and B move on a smooth horizontal plane in the same direction. Ball A has a mass of 3 kg and moves with a speed of 7 meters per second, while ball B has a mass of 2 kg and moves with a speed of 3 meters per second. So, let's find out the speed of each ball after the collision. For the question number 1, we should know the total momentum before equal to the total momentum after. So, write the formula MAUA plus MBUB equal to MAVA plus MBVB. After that, write the information you get from the equation, which is 3 multiplied 7 plus 2 multiplied 3 equal to 3VA plus 2VB. Simplify the equation and you will get the first equation. Because we have two variables, we must find another equation. The second equation we can find through the total kinetic energy. Total kinetic energy before equal to total kinetic energy after. Write the formula first. 1 over 2 multiply MA multiply UA power 2 plus 1 over 2 multiply MB multiply UB power 2 equal to 1 over 2 multiply MA multiply VA power 2 plus 1 over 2 multiply mb multiply vb power 2. After that, write the information you get from the equation, which is 1 over 2 multiply 3 multiply 7 power 2 plus 1 over 2 multiply 2 multiply 3 power 2 equal to 1 over 2 multiply 3 multiply VA power 2 plus 1 over 2 multiply 2 multiply VB power 2. Simplify the equation and you will get the second equation. Now we have two equations, so we can find the VA and the VB through simultaneous equation. From equation 1, we can make another equation as third equation, so we can substitute into equation number 2. So solve the equation until you get a VA equal to 3.8 meter per second. You will get a 2 answer for the VA, but you must choose one only. So you must choose 3.8 because UA already 7 meter per second. So the answer must VA equal to 3.8 meter per second. Next, we already have VA, so substitute into the third equation, which is VB equal to 27 minus 3 multiply 3.8 over 2. So, we will get the answer for the VB, which is VB 7.8 meter per second. Let's move on to question number 2. Verify that the total kinetic energy of the system is conserved. So, first, we must know kinetic energy before collision. We will use formula kinetic energy equal to 1 over 2 multiply MA UA power 2 plus 1 over 2 multiply MB UB power 2. Write the information given. So, kinetic energy before equal to 1 over 2 multiply 3 multiply 7 power 2 plus 1 over 2 multiply 2 multiply 3 power 2. So we will get the answer is 82.5 joule. Find the kinetic energy after the collision. Use the answer from the question 1. Kinetic energy equal to 1 over 2 multiply 3 multiply 3.8 power 2 plus 1 over 2 multiply 2 multiply 7.8 power 2 and the answer is 82.5 joule 2. So we can make the conclusion the total kinetic energy before and after is the same. Hence, kinetic energy is conserved. In this situation, the balls move on a smooth surface, so there is no external force acting on them, and the total momentum remains the same. Since no kinetic energy is lost during the collision, the kinetic energy of the system is also conserved. After the collision, the faster ball slows down and the slower ball speed up because momentum and kinetic energy are transferred between the two balls. When the faster ball collides with the slower ball, it gives some of its momentum and energy to the slower ball, but both balls continue moving in the same direction. This shows how momentum and energy are transferred between objects during a collision without any loss. To conclude what we learned, there are inelastic and elastic impact during collision. For all collisions, if there is no external force, momentum is always conserved. In an elastic impact, both momentum and kinetic energy are conserved. Energy is transferred between objects without any loss. In an inelastic impact, momentum is still conserved, but some kinetic energy is transformed into other form of energy. In conclusion, momentum is always conserved in collisions without external force. In Elastic impacts conserve kinetic energy, without inelastic impacts do not. This helps us understand how objects behave after collisions.
So that's all from us. Thank you.